we've got air, we've got water, and we've got rocks beneath the water. I've got bark, got a rock, and I've got the classic double acorn. We'll actually take the acorn out. Alright, so there's our acorn. Ready? Alright, so take a look at the acorn and the bark. We have to look at the ratio of how much of the bark is in the water, how much of it is out of the water. Then we look at the acorn, how much of it is in the water, how much of it is out. So I will take the camera and we will go halfway in. From least dense, the air, because it sits above everything. And then the acorn, because more of it sticks out of the water. Then the bark, and then water, the rock, and finally the rocks underneath it. We knew that the acorn and the bark were less dense than the water because they float. We were able to see the ratio of the acorn above the water and the ratio of the acorn below the water. Same thing with the bark, the amount of bark that's above the water versus the amount of bark that's below the water. And that's all about a percentage. Whichever has the greater percentage in the water is more dense. But the rocks are both solids. So the only way we could determine which rock is more dense, well, there's two ways. We could melt them, but then we would lose track of which one went underneath and which one went above. But we could find out the mass of it by using a balance, and we could find out the volume of it by seeing how much water it displaces. And that's going to be the next part. Finding the ratio between the mass and the volume, because that gives us a number which is density, which is a mass over a volume, which is just simple division. So, today we're going to be learning about density. Check that out. Look at all that math. This is what you're about to do. Scary. I know, but it's really not. Density is mass divided by volume. It is right here in your reference table, page 1 under equations, right under rate of change, which you guys seen before. Finding mass is pretty easy. You just throw it on a balance, you get the measurement in what happens to be grams, and you're good. So what does mass mean? It is a measurement of the object's resistance to acceleration. Pretty much the heavier something is, the harder it is to move it. And that's what mass measures. Therefore, your mass doesn't change whether you're on Earth or whether you're on Mars or whether you're in space. Your mass will always be the same. What is volume? A book. No. Volume is the amount of space that a substance or an object occupies. So how do you measure volume? Because I can't just take a ruler to this, I'm going to measure the amount of displacement. We have water. So water has a certain amount of volume. In this case, it has about 41 milliliters. Now, we need to figure out how much volume this bad boy has. In order to determine that, we see how much water it pushes up when we add this into the water. This has a certain amount of volume, and when it goes in there, the water has to move up and out of its way. Turn it to the side a little bit, let it slide in. So it started at about 41, now it's about 44 milliliters. So that has about 3 milliliters of volume. Now, if you look at this, this is a meniscus, meaning that the water kind of creeps up on the sides and it sits low in the middle. But if you look low at it, you can really see that water kind of bends up the side. We read the bottom of the meniscus. The top is the part that's really just like kind of crawling up the side, so we need to read that bottom of the meniscus. Well, we're going to find the density of a die, regular die, and a bolt. Let's get the mass of them. Right in the middle of the balance, 31.2 grams. Well, we got the mass, and we need to divide it by the volume. In order to get the reading, I come down nice and flat with it. 40 milliliters. So just so it doesn't crash into the bottom, I'm just going to turn it sideways so it has a nice slow slip. Knock any air bubbles off it because that takes up volume. Let's see what we got. The volume is just under 44. We've got our original measurement for water, and then we've got the measurement of the water and the bolt. So we need to get the difference in order to find the volume of the bolt. 3.8 milliliters. We take that, we plug it in for volume. In this case, we got 3.8 milliliters. 31.2 is on the top. 31.2 goes in first. 3.8 milliliters. This equals 8.21. What are my units? Well, we're going to find the density of a dye. Our mass for the dye is 5.5 grams. I get a look at it, 40 milliliters. And would you look at that? The dye was the same exact. We had 40 milliliters, and then it went up to 43.8 milliliters when we had the dye in there. The volume is 3.8 milliliters. If we do this math, we get 1.45 units, once again, grams per milliliter. So check it out. We've got our bolt, which is the same exact volume as our dye, but obviously it's heavier. When I first measured the volume of these two, I swore I made a mistake. I just can't believe that this is the same volume as this. They take up the same amount of space. Look at the size of this thing. It's huge, but at the same time, the base of it's really small, and it gets really narrow up here, while this thing is the same width all around. But if you melted this down into a cube, this would be the same size as this. Every 1 milliliter of bolt, there's 8.21 grams. And every milliliter of dye, we've got 1.45 grams. Both of these sank in water. That's because their density is greater than water. Back when I had my crappy BMW. Don't get me wrong, I love BMWs. But this thing was a piece of crap. I bought this for the exhaust. So whenever they sell you a bolt and a nut, they sell you the same kind of metal. But obviously, the bolt is much larger than the nut. This is the nut, right here, nut, bolt. So since it's the same kind of metal, let's see if their density is going to be the same, because it's made of the same exact material, but because they have a different volume, they're going to have a different mass. But the ratio between mass and volume should remain the same. 11.3 grams. I got the volume set back at 40 milliliters. When I add this in, let's see what it changes to. Get the bubbles off. What is that volume? I read that to be about 41.3 milliliters, and the original was once again 40.0 milliliters. So I started at 40 milliliters, but you can really start wherever you want. You can start at 37.5, 39.4. It doesn't really matter. I just like to have it at a nice round number. But as long as you get the initial volume and the volume after whatever you throw in there is added, you'll get the volume of the actual product, in this case, the nut. So we've got 1.3 milliliters after that math is done. 1.3 milliliters. 11.3 grams divided by 1.3 milliliters equals 8.69 grams per milliliter. So if you notice, the bolt and the nut, I already told you, are made of the same exact material. So the density should be the same exact. Now, one thing I need to point out is that we're only measuring to the tenths place for each. And even the tenths place for milliliters is very hard to find. Now, I was pretty close, because if the volume I measured was to the hundredth place, I would have been able to find out that it was 1.37 milliliters. So if I go back and I go 11.3 grams divided by 1.37, I'd get 8.24, which is much closer to this. So that just proves that there's error in the human eye, that no one's perfect, and most importantly, that density for an object that is made of the same exact material, no matter the volume, no matter the mass, will remain the same. So once you get the measurements and you understand what the mass is and what the volume is, you can find out the density.